you've got to get just the right angle. See, like that. And then it will go.
Could this go down any set of steps then, really? Like, does the height matter?
No, we'll do a chair in a minute. Chairs are a bit tricky. Well, we've got it in one. It's difficult to do that. So it needs a lot of redesigning, really, especially to the foot. Okay, should we try a chair?
Mm-hmm.
So now get ready to switch everything off. And switch everything off. Right, forwards a little bit. No, forwards. Stop. Now crane up. That's it. And get ready to stop. And stop. Forwards a little bit. That's it. Okay, now see if you can reverse up to the edge without falling off. Bit more. No, bit more. Tiny. No, that should be okay actually. Now crane down. And get ready to stop and stop. Right, so now reverse a tiny bit. Just a tiny, no, reverse a tiny bit. And crane up a tiny bit. That's it. Woo, and reverse a tiny bit. That's it. And this is so nerve-wracking, this bit. Right, you want to do reverse and up at the same time. Can you do that? That's it. And I'll just leave it. Fingers crossed that it doesn't fall over. Okay, and switch the reverse off. That's it. And I'll just wait till it touches down. And stop. And reverse.
I'm going to put it in the bin.
Very good. I'll give that a 9 out of 10, I think.
Oh, Matt got a 9 out of 10.
Yeah.
So how did you balance the weighting so when it comes up and down it doesn't fall over?
Oh, that's really difficult. The really difficult bit is where you're just on the edge coming down. So you have to have that at a sufficiently big angle so that the foot comes down here, not here. So I can change that by, if I move that, bend that a bit, that changes its angle, so that makes it much easier to come downstairs because the foot will touch down much further away from the see, it's right out here, and that means it won't fall over like that. But the trouble with doing that is you get the mast sort of leaning forward, so it tends to tip, the weight of the mast tends to tip it forward. So there you can see if the mast is too far forward it will tend to tip forward like that.
So wait, so what determines the height of the mast?
The height of the stair. Like this mast is it doesn't need to be anywhere near this long for these stairs. I mean, it needs to be kind of oops. It needs to be that long, which means it's about 3 inches too long. But these are quite shallow stairs. Strangely enough, shallow stairs tend to be more difficult than very high stairs because there isn't so much space for the foot to move away from the riser of the stair.
So can you talk me through what you're doing as you do it?
Well, I'm just attaching the longer mast really. Now, because it's a lot longer, it's going to overbalance forwards, so I have to change the angle of the back wheel like that, and then attach the bit of fishing line. That's going to go around the pulley twice because then it gets more grip. And hook onto the top. And then we should be good to go.
So how have you attached it at the bottom?
That's just a rubber band that keeps it in tension so that the fishing line is always pulling onto the pulley, so the pulley is always exerting a force on the fishing line. And just a bit more like that because it tends to snag on those things. Right, now we can climb onto a coffee table. So with the mast like this, it shouldn't overbalance. No, that's right. The only limit to the length of the mast is whether it tips the robot over like that. So if you were to make the mast out of carbon fibre or something, you could make it a great deal longer than that. So now onto the table.
So instead of using the stairs, the carpet on the stairs, it's using the...
Yeah, it's using the... You do have to have a carpet, I'm afraid, or it just won't get enough grip. Strangely, climbing onto tables is easier than going up and down stairs because you've got so much more distance here for the foot to touch down further away from the table.
So the bigger the distance, the more easily it works.
Yeah. Right, so now I'll come down again. So the foot's touching down a bit crooked, see that? And that's why it tends to go over to one side. The control's just two simple reversing switches with an off central position, so that's forward and that's back, and each motor's got two wires controlling it. So that's a really simple way of controlling a robot, but the thing is, the difficult part of designing the robot is designing the mechanics of how it goes up and down stairs. The remote control is a separate problem. So you can separate the two problems.
Mm-hmm.
And that way you don't have to spend any money on that, and it's fairly reliable.
And do you want to talk me through the mechanics and the motors of the actual...
Yeah, okay. So it's got two motors. It's got that one there, makes it go forwards and backwards, and then this one here works this pulley wheel, and that makes the mast go up and down. And that tends to be very, very problematic because that has to be surprisingly powerful. This one doesn't have to be powerful at all, but this one, to lift the weight of it, which is, I don't know, it's about sort of 300 grams or something. To lift 300 grams is pretty hard, and ideally it should lift it a lot quicker than that, but because they're only cheap motor gearboxes, that's the best I could do. That motor actually is quite an expensive motor. That's because otherwise it'll burn out.
Let's just do a close-up. So, do you want to talk about the gears at all?
Well, they're just cheap motor gearboxes. And you have to select the number of cogwheels to sort of optimize the performance of the thing.
And how did you select that?
You just try different numbers of cogwheels. That there is a dodge to get it to transmit more power. You have the end of that shaft, you have another bearing, because otherwise the cogwheels will skip over each other because the shafts get pushed apart like that. So that's a useful dodge. And I've got one on this gearbox as well. I've done it with a zip tie on there. It just holds the two shafts together so that the wheels don't jump over each other. That's it, I think. Can't think of anything else to say.